4.3 is representations of reactions. Our outcome is I can represent a given chemical reaction or physical process with a consistent particulate model. So, balanced molecular, complete ionic, and net ionic equations offer different forms to represent a chemical reaction. So, we choose what form to use based on the context in which we're going to be using it. So, balanced chemical equations can also be translated into symbolic particulate representations. So, these are models that we can use to show chemical and physical processes, to predict bonds, or to determine limiting reactants. So, here we have a diagram, and we want to know which of these reactions best represents the reaction. So basically, I'm just looking to figure out what my reactants and products are. So using my key, I see that I'm starting with some molecules of NO, and I also have some molecules of O2. And I also see that I'm going to have some of these O2s left over as a limiting reaction. So I know that in my product, which is NO2, that there's one nitrogen. And if I count the number of nitrogens that I'm starting with, I have 1, 2, 3, 4, 5, 6. So that tells me that I'm going to use all 6 of those, and I have some oxygen left over. So that lets you work out that 2-to-1 ratio. Here's another particulate representation. This one is showing us a mixture of carbon disulfide and oxygen in a container that are reacting together. This is showing the reaction mixture at completion. So which of the following is going to best represent the reactants that would result in this set of products? So looking at choice C, the products are 2 molecules of carbon dioxide and 4 molecules of SO2. So in order to make these, I'm going to need 2 carbon atoms and 4 sulfur atoms. So I'm going to get that from 2 molecules of CS2. We're also going to need a total of 12 oxygen atoms to make those 6 molecules. So I'm going to need 6 O2 molecules total here. Question 3 is showing us a solution of potassium hydroxide and calcium chloride. So we need to write the chemical equation for this reaction. So these are both aqueous solutions. They're going to react and form a precipitate, which is calcium hydroxide. And our potassium and chloride ions would remain aqueous. So choice B shows our solid calcium hydroxide being formed. That's insoluble based on the solubility rules. And it also shows the potassium and chloride ions floating around as spectator ions. Question 4. We're starting with a reactant mixture, and we want to know what is going to show us the completed amount of products, like what's the most we can make. So we're forming NH3. So looking at the number of nitrogen atoms that I have, I've got 4 of them. And that's going to be the most number of NH3 that I can possibly make. So in order to do that, I'm going to need all of those oxygen molecules except for 1. So this is going to leave behind some oxygen as a excess reactant. So for the reflection question, explain the particulate model representing a net ionic equation. How is that different from a complete ionic equation? So the particulate model showing the complete ionic reaction would need to include those spectator ions, whereas the net ionic would not.